Hmm. Good morning to all of you. Welcome you guys. Welcome you all. Yeah, first of all, please do confirm the audio video quality. Is the audio video is clear to everybody? Hmm? So is the audio video is clear to everybody? Tell me now first of all. Am I audible? I think we are live. Chalo. Very good morning to all of you. So the last class हमने डिस्कस किया the most expected questions in the network theorems. आज हमने डिस्कस करने वाला ट्रांसिएंट्स के बारे में डिस्कस करने वाला है. ठीक है, लेट्स स्टार्ट आवर डिस्कशंस एंड टुडे वी आर गोइंग टू सी द most expected questions in the transient का concept. Transients is a very important topic. So here transient में आपको जरूर so minimum 2 marks question मिलेगा. minimum 2 marks मिलेगा. So इससे भी ज़्यादा भी होगा कभी कभी टाइम. So but definitely 2 marks question is compulsory from the transient concept. ठीक है. So let's start our discussion everybody. Yes. Am I clear to everyone? Audio video quality is clear na? Chalo. And before this we have an announcement from Unacademy. So that is now you can have a look at now in GATE 2024 the top rankers from Unacademy only. You can see now 7 AIR ranks from Unacademy students. The electrical, CSIT, ECE, CH, IN, PI, NM, all these top branches, the toppers are from Unacademy only. You can have a look at now. And these are the new batches we are starting. You can see now here we are starting the new batches are digital as well as EMFT हमने शुरू किया. You can do follow these courses. To enroll for it you can use a code of B V Reddy. And the plus features you can see. The plus features, raise the hand options, class doubts, polls, daily practice problems, educator communities, learn comfortable home, study material, unlimited access, and the top educators of the India. Chalo, let's start our discussions now here. Take the first one. Consider a DC voltage source is connected to a series RC circuit. When the steady state reaches the ratio of energy stored in the capacitor to the energy supplied by the voltage source is right. Chalo. So they given the problem as what? Tell me now here. So the DC source which is connected to, so here supply now here a DC source for a series combination of RC. Now they ask him to find the ratio of the energy stored to the energy supplied. Yeah, you tell me now here, which element can able to store the energy? You tell me. Which element will store the energy? Capacitor will store the energy. Now this is my R and this is my C. Now can you tell me now here voltage across this capacitor we can find now. Now you can see now here the switch is closed at t is equal to 0. Before that there is no energy. So here that means what we can say now here initially capacitor will behave like a short circuit, that is VC of 0 minus which is equal to 0 now tell me. And VC of infinity is how much we can say? That equal to V. Now you can tell me now VC of t which could be given as what you tell me now here, final value plus initial value minus final value into e power minus t by tau. Tau equal to what you tell me now, RC. Now find out the VC of t. So VC of t हमको will get it as what tell me now, V. Yes, 0 minus V into e power minus t by RC. This is the voltage across the capacitor. This is the voltage across capacitors. Right. Now you can see now here from this we can find the current in the circuit now here IC of t. If I call what the IC of t, I equal to what I can say now here C into dVc of t by dt. I equal to dVc of t by dt. Now you can tell me now here IC of t, which will be given as C. If I differentiate it now here, so first term to 0 banega, minus that is Vc by what I can say now here Rc into e power minus t by Rc. So then what I can say now here IC of t, which is equal to what I can say now here V by R into e power minus t by Rc. Right. This is the current through the circuit now here. Same current will pass through the resistor as well as a capacitor. Now you tell me now here. So we'll find the energy. So you tell me now what is the energy now here. Energy across capacitor, which is given as what I can say now here. I capacitor energy, which is equal to 1 by 2 CV square. This is the energy stored by the capacitor. Energy stored by the capacitor. Now let's see this thing, how much the energy supplied by the source. Now the energy which is given as, we need the energy supplied by the source, which will be given as integration of power, I can say now. Integration of power will give energy. So that is given as what we can say now in steady state means what I mean now 0 to infinity. Power which is equal voltage into current. Voltage is a V and current is how much you tell me? V by R into e power minus of t by RC into dt. Now simplify. So how much will come this power you see? By integration, so we can get this energy supplied by the source. It will come to be a what I can say now here V square by R integration, so that is e power minus t by RC by minus 1 by RC, and the limits are 0 to infinity. Now you can see this thing, how much the energy supplied by the source. You can see here this minus, this is what we have, this is V square by R into this will be equal to minus RC and into e power upper limit, which is equal to 0 minus what, tell me now here 1. So then what is this energy you can see here? This will be equal to minus will get cancelled, that is CV square. This is what you tell me now energy supplied by the source. Now they are asking to find what, tell me now here, that is a ratio between what, tell me now here, energy stored in the capacitor to the energy supplied by the voltage source. That means energy stored means capacitor energy by energy given by the supply now here. So that is what, tell me now here, of CV square by what, CV square. That is what you tell me now 1 by 2. So what's the answer you tell me? Option C. Right, all of you. Beautiful problem. Next one. For the circuit shown, different time constants are given. What are the charging and discharging times? Mean how, what will be the charging time constant and what will be the discharging time constant, they asked to find. Right. Tell me the charging time constant and discharging time constant. charging time constant. Now charging, doing charging in the sense capacitance is charging. So when this capacitor will charge now, when the switch is close करने के बाद charge होगा. That means what, tell me now here. So when the switch initially switch is in this position. So here when the switch is in this one, that is t is equal to 0 minus, this capacitor will get charged. Yes or no? This capacitor will start charging when this switch is in this position. So here, thereafter, when the switch is removed, that means when the switch is here, then when the switch is connected to here, then this capacitor will get discharged. They are asking to find charging and discharging times respectively. Yes. So now you can tell me now charging time constant, discharging time constant. So what we can say now here, tau. Tau equal to what, tell me now here, R into C. Tau equal to what, tell me now here, that is R equivalent into C equivalent. So you tell me now here, the capacitor will start charging. The given T is equal to 0. Yes, T is equal to 0, switch is closed now. Yeah, you can see now here, T is equal to 0, switch is moved to here, this position, right? And when this is in this position, then what is a capacitor will start charge. Okay, they should mention this as which capacitor has to charge. I'm considering this capacitor. If we consider here, actually when the switch is here, this capacitor will charge, right? When the switch is here, then this capacitor will charge. So that means, let us find out now here when the switch is in these positions. So then which capacitor will charge, you can see now here in this position, this capacitor will charge. How much the time constant to tell me now here? This is 5 into 10 power 3 into C. How much the C value you can see now here? This is 0.5 into 10 power minus 6. Yeah, simplify, how much will come here? 25. So here we have, that is, yeah, 2.5 into 10 power minus 3 seconds. Yes, this will come it as like this now here. And thereafter, if we talk about discharging time, what will be the discharging time, you tell me now here in this case. So which capacitor will discharge, you can see now here. So when the capacitor each switch is changed to here, now in this scenario what happens now here, this capacitor will charge now here. Now that is also tau. Let us say tau 1, this is a tau 2. This is also charging only na. But here this resistance is how much now here? 1.5K. No, 6K. 5 plus 1, 6K. Both are K only na. That is 6 into 10 power minus 3 into what, tell me now here? This is 0.5 into what, tell me now? 10 power minus 6. Yeah, you can tell me now how much will come here. This is 3 will come now. So it will come to be a switch positions सही ले लिए ना. When the switch is here, this is a path. When the switch is here, then the path will be shifted, right? So both two capacitors are given. So here, what should be now here? Both will be, we are getting at charging only na, isn't it? Both are charging only. When the switch is here in this scenario, what happened? You tell me now here. This capacitor will get charged. And T is equal to 0 minus. Yes, tell me now T equal to 0 minus if we consider, and this capacitor will get charged. How much is capacitance here? You can see now here. So both cases we are getting a charging only, na? Both cases we are getting charging only. It is not a discharging. Both are charging only we are getting. T equal to 0 minus if we consider. So the time constant which will come to be a what, tell me now here? 5. This is 5 plus 1, 6k. 6 into 10 cube into what, tell me now here? Yeah, 1 by 2 into 10 power minus 6. So then tau will come to be a what, tell me now here? 3 into 10 power minus 3. Yeah, I got this is the time constant at t is equal to 0 minus. That is t less than 0, we can say this one. This is the time constant for t less than 0. And for t greater than 0, kya hoga, you tell me now? In this case, the switch will come to in this position, na? Switch will come to in this position. Now there is no discharging path at all here. Might be here. If we have one short path is there. If we have like this, नहीं वो भी नहीं होगा. Connect the two capacitors. Yeah, lower end is connected to ground only. Yeah, both are connected to ground only. If we have these connections, no, yeah. Okay, so we'll do it. So take the next one. Meanwhile, let me think about this thing here. So take the next one. If 1 microfarad yes, it doesn't have any discharging path. Yes. So how it will get discharged? Now no path na. Yes, let's see this thing. 1 microfarad capacitor charged through 2K resistor by 110 volts DC supply. The initial growth of capacitor will be. The initial growth of capacitor. That means growth means what tell me now here? dV by dt. Right? They given it as what tell me now here? A capacitor which is connected to the RC network by DC supply. So that means VC of 0 minus, which will be a 0, and VC of infinity, which is the steady state, will be a 10. And the VC of t, which will be given as what we can say now here. So 10 minus 10 into e power minus t by RC. All of you. Now they are asking the growth means what will be now dVc of t by dt. It should becomes what will be now minus 10 by, that is RC into e power minus t by RC. So then, so dVc of initial growth means t is equal to 0 plus, which will be equal to 10 by RC. R value is what will be now 2 into 10 cube into C value how much now here? 10 power minus 6 into e power minus t value 0. So it will come to be what we can say now here 3 zeros, that is 10 into 10 cube by 2, that is what will come here. Okay, he kept like this only. Okay, we'll keep like this only. So they given this as what I mean 5 by 10 power minus 3. So this is given as what we can say 5 volts per milliseconds. They kept like this. Denominator one they kept. See the options now here. They given denominator milliseconds given now. Keep the 10 power minus 3 denominator only. Next. The switch. Okay, open at t is equal to 0 after the network has attained a steady state with the switch closed. Then find Vs of 0 plus across the switch. Okay, the switch K is open at t is equal to 0. Switch is open at t is equal to 0. That after that network has attained a steady state with the switch closed. Okay. Now they are asking to find what to tell me now here. So what will be the Vs of 0 plus? Now you tell me now at t equal to 0 minus. See the scenario, what happens? What will happen? You can see. At t equal to 0 minus. Now you can see now here. What's going to happen? Tell me now here this inductor. So the switch is what tell me now opened or closed now. T is equal to 0, switch is open. Before that is closed only now. If you draw the circuit now, tell me now switch is closed at t is equal to 0 minus. 0 minus switch ने close किया. Right. And so this inductor. So inductor will become short circuited. Capacitor will become open circuited. Capacitor is open circuited. Inductor is shorted. So this is V and this is resistance R1 and this is R2. Now you can tell me now here the current will go in this path mein jayega. So here this current which I can call it as what, tell me now here IL of 0 minus, and here this voltage if I say this is VC of 0 minus. So what we can say now here IL of 0 minus, this value given as what, tell me now V by R2. Next, what is the VC of 0 minus, you tell me now here, which is equal to 0. Got it? First thing. Next, Now what we can do here, we need to get at t is equal to 0 plus. Draw the circuit at t is equal to 0 plus. T is equal to 0 plus, that is a transient state. Now tell me, in transient state, so you can see now here how this capacitor will behave. You tell me now. Capacitor, which will behave as what, tell me now here? Short circuit with the initial values. Inductor will behave like a open circuit. Right, now we can replace now here. So at t is equal to 0 minus 0 plus we are doing now here. Whatever switch now, switch is open here. Switch is opened. Now draw this circuit. So capacitor which is shorted like this. Switch is opened. Resistor is there now. And this inductor is opened with the initial current. So there is some initial current is there now. So the inductor, and here this is R1 and this is R2, this is V. अभी हमको ये voltage चाहिए. This voltage is required. Vs of 0 plus. This current is how much now? V by R2. Right. So you can see now here this current is same only now V by R2. So this is V by R2. So I need this voltage only now. So then what is this voltage, you tell me? That is Vs of 0 plus. This should be given as what, tell me now here? So that is V by R2 into R1. V by R2 into R1. So कौन सा option you tell me now? Option A. Done. Next one. Now you see this thing here. Given initial charge C0 is given as 400 microcoulombs. In steady state, find the charge in 1 microfarad capacitor. Right. So they given the capacitance value given C0. So this is, and initially here they given this value. So here this is the capacitance C0 value given, and they ask you to find initial charge. So this is Q0, not this is Q0. Q0 is given as 400 micro given, right? So C0 value, I can get the voltage I can get now. That is given as Q0 by C0. And Q0 is how much, you see this thing, 400 micro by, so this is 5 microfarad. So this value is how much, you tell me now? 100 volts. Right. So that means this voltage which we have it as how much? 100 volts. Now in steady state, we need the, in steady state capacitors will behave like a open circuit. So that means how much voltage accumulated in the each capacitor? 100 volts only. 100 volts. They are asking the charge, they are asking here. How much the voltage across this capacitor is also 100 only now. So that's why charge across 1 micro, which is equal to what I can say now here? 100 microcoulombs. Right. Next one. The switch in the circuit of figure has been closed for a long time. It is open at t equal to 0. Now they given the option V of 0 plus and I of 0 plus. Okay. Yes, switch is open at t is equal to 0. Now you tell me now, first of all, at t equal to 0 minus, analyze now here steady state. Now you tell me now in steady state, so capacitor will behave like a open circuit. So how much this circuit you can see now here, and switch is open. Yeah, sorry, switch is closed now. Switch has been closed for a long time. At t is equal to 0 minus, which is closed. And the capacitor, it should be steady state. So then this is 1 ampere, and this complete 1 ampere current will go here in this path mein jayega. This is 1 ohm. Then how much this voltage you tell me now, V of 0 minus, which is equal to 0 volt, that is V of 0 plus, and which is also equal to 0 only. Next, now tell me now here immediately at t is equal to 0 plus, kya hua you tell me? At t is equal to 0 plus, switch is opened. Right, this is 1 ampere, switch is opened, and this capacitor is shorted, transient state. Now you can see now here this value is 1, this current is 1 ampere. So we can write it as what tell me now here, I of 0 plus, which is equal to how much? 1 ampere. I of 0 plus is 1 ampere and V of 0 plus is 0. So constant option you tell me now here, option C. Next one. Right, following now everybody. Next, in the given circuit, see, look at now here, the switch is moved from position A to position B at t is equal to 0. Right. The current I through the inductor satisfy the following conditions. Look at now here, they given I of 0 given as -8. Okay. Now tell me now here, initially at t is equal to 0 minus, where is the switch you tell me now? At t equal to 0 minus, switch is at position 1. So when it is position 1, so this is a current will flow like this. We can write it as what element of this current. I can say this as IL of 0 minus, and that should be given as what we can say this is E1 by 3. Okay. So that is given as minus plus 8 now. So from this I can say this E1 is equal to how much now here? 24. Right. Next. Now at t is equal to 0 plus. Now tell me now at t equal to 0 plus, see the scenario now transient state mein hoga. So transient state, so in this case which is at position B now. So which is at position B, and you can see now here inductor which will behave like what you tell me now here, transient state. We can redraw the circuit now here, that is it is like a inductor is open circuit now with the initial current. So then this value will come to be a what, tell me now here, resistance is there, and this supply inductor is open circuited, but it has some initial current is there now, and the direction of this current is like this. Now so this is resistance R, this is E2, and this value of current is how much now here in this direction current. This right side is minus and left side is plus. Now, so then this voltage, which could be a, if I call it as VL of 0 plus. So how much this value you can see? How much this value tell me now here? In this case, same kind of pass hoga na? Right. If we write this thing, this current which is equal to 8 amps only na? This current is also 8 amps only. So now this is positive, negative. So this is 8 into R. We can apply KVL in this loop. We can apply KVL in this loop now here. So you tell me now what I will get now here. So this is E2. It should be equal to what, tell me now? VL of 0 plus 8 into R. Right. Now, so what we can say now here? What is basically VL of T, which is given as L into DIL of T by dt. So here from this I can say this DIL of 0 plus by dt, which is nothing but VL of 0 plus by L banega na. They given this value given us how much you can see now, 3 given na. This value given us how much you can see now here. This value given as a 3 given. So that means from this what we can write now here, this is E2. It should be equal to what we can say now here, VL of 0 plus. So this is into L. Inductance value given 2 is given now, that is. So here this direction we need to have a current, but it is opposite direction now. So that's why what we can say here, minus. So this is minus 6 plus what, tell me now here, 8R. And another thing is given as what, tell me, I of infinity. So I of infinity is how much, you tell me? How much is I of infinity value? This is means what, tell me now, E2 by R. So this direction. So then this value is a plus 4 now here. Now I can replace now here E2 equal to what, tell me now here, 4R. So simplify this thing here. This is 4R. Yes, which is equal to minus 6 plus 8R. Then it will come to be a what, tell me now here, by simplifying this thing here. Yeah, 6 is equal to what, tell me now, 4R. From this, R equal to what, tell me now here, 6 by 4, which is equal to 3 by 2. 1.5. We need to find what, tell me now here, R value. So sorry, what we are getting now here, 1.5 we are getting. Check it now here. हमने कोई गलत किया क्या हमने इसमें? That is E2. So minus, so this will be a minus VL of 0 plus, and which is equal to क्या हुआ इधर, हमने कोई गलत किया क्या हमने? E2, this thing is 8 amperes only, no? Correct. Yes, 8 amperes only. Mm-hmm. So this is what we are getting now here. This is 8R, right? 8R E2 equal to what element now? This is 4R. So this value VL which will be a what element now here? This is minus 6 plus 6 hoga. This is what element of 8R. Now it will becomes what element of here? 6 is equal to what element of here? 4R. Hmm? Now this is R equal to what element of here? 6 by 4. 1.5 we are getting. Check karo. So did anybody got any other answer? You tell me. हमको 1.5 आया. Check करो. 1.5 you got the same thing or any other answer you got, you tell me. 1.5 is answer. Okay, 1.5. Everybody got the same thing. Check करके बोलिए. कोई दूसरा आंसर आया? Right. And see the next one. In the network shown, the switch is open at t is equal to 0. Prior to that, the network was in steady state. Vs of t at t is equal to 0 is Vs of t. So here switch is at t equal to 0, switch is closed. At t is equal to 0, switch is open. Okay, now you tell me now t equal to 0 minus, see what happens now here. T equal to 0 minus, what will happen you see? At t is equal to 0 minus, switch is closed or open. So here switch is closed. When the switch is closed now here, इस path में जाएगा ना here. So if I call this current is IL. What is this thing? IL of 0 minus. It should come to be a 10 by 10, 1 ampere. Right. Now you tell me now here. At t equal to 0 plus. At t equal to 0 plus. See what happens now here. Switch is opened. Then it will be, this is the path. Now tell me now here. Immediately opened. So then capacitor which is in. Capacitor is short circuited and inductor is open circuited. Capacitor is shorted and this inductor capacitor which will be equal to 5 and this is what we can say now 10. And what about this inductor is open circuited with the initial values. Initial value of current is how much? 1 ampere. अभी ये value चाहिए ना. This is Vs of 0 plus. Now this is 10 volts. Here tell me now this is how much will come. Right. So this current which is equal to 1 ampere. So then this voltage we can apply KVL, we can apply, we'll get this thing. So you tell me now here 10 equal to what we can say now 5 plus 10. Okay. This is 10. Yes, plus Vs of what we can say now 0 plus. So then Vs of 0 plus, it will come to be a what element of minus 5 volts. Yes, minus 5. Okay. Next one. Switch K is closed at T is equal to 0. Find Iy of 0 plus. Find Iy of 0 plus. Now switch is closed at T is equal to 0. So you tell me now here at T equal to 0 minus. Tell me the scenario. At t equal to 0 minus, what happens, you see? So switch is opened. When it is open, now here you can see now inductor current we can find. Switch is open and here is the supply is how much? 120, sorry, current source. Now here this is the current source which is equal to 120 amps. So this is 800, right, and this is 400 and this is 200, right, and this is 40, and this current we are finding that is IL of 0 minus. What is this IL of 0 minus, you tell me now here? So IL of 0 minus, now we can apply current division, we can apply now here, that is 200 by, that is 240 into 120. So this is 2, now here this is 100, which is equal to how much now here? 100 amps. This is, we got this IL of 0 minus we got now here. Tell me now t equal to 0 plus kya hoga, you tell me. At t equal to 0 plus which is closed. Then transient state now. Now redraw the circuit now kya hoga, you tell me abhi. Now this is 120 amps. Switch is closed. Inductor is open circuited with the initial current is there now. How much the initial current? 100. And here is another resistance. That is what we can say now 200. And this is 40. And this is 800. And this current is what you tell me now 100 amps. हाँ, so अभी ये चाहिए ना हमको. Yeah, tell me now what will be this current. So here can I say this value current is directly 200? No, we can't say here. So here we need to understand now here this voltage is 0 and this voltage is also 0. If I call this voltage is something Vx, if I consider, we can write the nodal equations here to get the Vx value. So this is the entry current which will be given as, yeah, tell me now here, minus 120. So this is minus 120. We'll write here at this location. So that is Vx minus 0 by 800 plus leaving current which is equal to 100 plus that is Vx by 200 which will be equal to 0. So if I take the Vx common, then it is 1 by 800 plus 1 by 200 and that will be equal to what? Tell me now, minus 100 banega. So that means Vx, we can say this as 800 is LCM. So will come to be a, so 800 we have, so then this is 1 plus what element of here? 4. Then it is what element of minus 100. Then Vx which is equal to what we can say now 5 by 800 which will be equal to minus 100 banega na. Now you can see this thing Vx value. So this is Vx value will come to be a what element of this is 20. So why this Vx value we got this much value, huge value? Check karos, आपकी ये आया minus 1600. Check it. We got this much voltage, very high voltage. So this is minus 1600 volts we got. Okay. Then thereafter from this we can get this currents, we can get it. So then this is minus 1600 ulta hoga. That means this current which will be equal to 8. This current is 8 amps. Okay. This current is 8 Yeah, this current which will be a 100 is going. Yes, so this means this current is 8 means how much this current we should go, and this must be 18. This is 92 we should get now. This is 92 amps. If this is 92 amps, so that means now we need this downward current. How much will the downward current is? 120 minus 92 now. Oh, 16,000. Okay, 16,000, not 100. Okay, 1,000. So then this current is how much you tell me now here? 16,000 by 200. So this value which will be equal to 80 na? This value is 80. If this value is 80, so then this value is at 20, we should go here. Then this value should be a 100. So that means this current. So finally IY of 0 plus. This is how much you tell me now here? 100 amps. So option A, sorry B. Okay. Yes. Yeah, you can tell me now this one. So you can see this thing here, Vs initially this thing, what is the VC of 0 minus. So this is how much we can say steady state 1. This is nothing but what we can say now here, supply. This is Vs. Okay. So this is Vs of t. What we can say, this is 1 into u. So u of minus t na. And what is the Vc of infinity, which is equal to 0. Now what I can say now, Vc of t, which is equal to Vc of infinity final value plus initial value minus final value into e power minus t by tau. Tau equal to RC. Now simplify and get it. Now here Vc of t will come to be a final value to 0i and initial value is 1 minus 0 into e power minus what we can say now t by RC. This will come to be a 1 into e power minus t by RC now. This is Vc of t. So answer option you can see now here, option A. Fine. Okay. Yes. Okay then. Yeah, that's it for today's sessions, and we'll meet in the next session. Next session we'll continue our classes. Okay then, see you. Bye bye.